In this episode, I will show y'all how to do a binary search. Alright, first things first, I'm going to open up my terminal, and I'm going to go to my YouTube examples directory, and I'm going to type in code space period, and this is from last video, so I'm just going to open up the Explorer here. I'm going to add a new file. I'm going to call this file binarysearch.go. Alright, and in this, I'm going to declare this is the main package. I'm going to import the FMT library, and we're going to have two functions here. One is going to be the binary search function. Oops. And one is going to be the main function. All right, in the binary search, we're going to have two parameters and two return values. So the two parameters are going to be the array, and it's going to be an integer array. And we're also going to have a parameter for the target number. It's going to be an integer. And the result value is going to be a Boolean and the index. All right. So first things first, we are going to do this right here. Okay. And we're going to set our low and high value. So our low is going to be, again, this shorthand and go. I'm going to make this larger for you guys as well. Is this colon and then the equal sign. And yeah, so we're going to have two values here, a low value, and this is going to be set at 0, and a high value. This can be set at the length of the array. Okay. And the thought process behind this low and high is for indexing. So a binary search, you have to sort the array, and then after you get that sorted array, you kind of cut it in half at that midpoint, and you try to look for the target value, right? And if the target value is less than the midpoint, then you want to look at the left-hand side of that cut. Vice versa with the right-hand side, right? So if the target value is greater than the midpoint, then you will look on the right-hand side. I'll explain it more as we go on. Okay, so we declare those two values, the low and high, and we're going to do a for loop. So in Golang, there isn't really a while loop, so this for loop will be our while loop, which I think is pretty cool. So you can kind of think of this as while low is less than high. That has helped me think about this. And moving on, we're going to declare our midpoint. So midpoint is going to be our low plus the high minus low. And then we are going to divide by 2. And our current value is going to be the array at this midpoint index. Okay? So after we initiate these two values here, we can start checking our conditions. So the first condition is if the current value equals the target, then, well, I mean, that is that's a perfect case, first try, and this is what we want right here. So if this happens, is what we want to return, so we first need to initialize the result value, so the result is true, and we want to return result and the midpoint, which is, I have I up here in the function return values, but it's actually the midpoint. I is just, it stands for index up here. Okay, and then we have an else if. So if the current value does not equal the target, then we're going to go down here. So I actually need to forget to set a condition here. So if the current value is greater than the target, we want to set the high equal to the midpoint, and we want to go down here to our final else statement, so else, and this is just the other option. You could have done this else statement up here with a different condition. Then this final else is the low is going to be equal to the midpoint. And this is really important right here. You want to add 1, right? Because if you set the low equal to the midpoint, this value has already been checked, right? It's been checked up here at current value. And so you want to add 1 to that so your index is greater than that, okay? And yeah, so outside the for loop, we can expect that, there was no flags, this if statement never happened, therefore there was no return result or midpoint. So outside the for loop, we can say result is equal to false. Oops, false. And you actually don't need this shorthand right here, so I'm going to delete that colon. And then we're going to return, if I could spell, that would help, return result and the midpoint. Oops. Well, let's set I equal to -1 here. Just a extra flag because I have 2 return values up here. I need 2 down here. That's just the way I did it. You don't have to do it that way. So return I, and let's do that. Okay. And so that is our binary search right here. And I'll move on to a test case. Okay. So test case, let's create an array, initialize an array. It's going to be an integer array. Oops. And let's just have the values like the multiples of 5. Okay. So 5, 10, 15, oops, 20, 25, 30, 35, 40. Okay. And our target is going to be, we're going to say 35. So I'm going to print out the results. So I'm going to do fmt.println, and I'm going to query this function up here, so binary search, and I'll pass in the array and the target. Okay. And I forgot to import. I just realized that. I thought I did, but I guess not, and that's okay. And I'm also noticing a conflict here. I just need to comment this out right here, and it should be good now. And yeah, just double checking everything here. Everything looks good. So we should get true, and then we start at 0. So 0, 1, 2, 3, 4, 5, 6. So we should get a true and then a 6. So I'm going to type in go run binarysearch.go, and there's our expected result. And keep in mind, this only works with a sorted array. So this is incrementing by 5. It is a sorted array. It's in order. What happens when we don't have a sorted array? So I'm going to create another array here, and it's not going to be sorted. And let's do just random numbers here. So I'm going to start at 10, do like 7, 5, 23, 58, 90, and then maybe like a 2. Okay. And if I do the same thing, and let's just say at the end I have 35. Okay. So the target is in this, right? But because this array is not sorted, it will not work properly. And we can test that. So let me save this, and let me clear this, and let me run it again. So false, -1. Even though, yes, this target number is in this array, because it is not sorted, it does not work with a binary search. You have to have a sorted array for a binary search algorithm to work. All right, that's it. I hope you guys have a great rest of your day. If you have any questions, leave them in the comments down below. And yeah, you guys have a great day.